Welcome to the deep dive. Today, we're really getting into something pretty intense happening in tech right now.
Yeah, it's this huge battle, really high stakes in the AI chip market. We're focusing mainly on AMD and NVIDIA.
Exactly. It's not just about chips, is it? It's like who's building the engine for this whole AI revolution.
That's a good way to put it. The foundational power.
So we've got a whole bunch of material here, articles, reports, company updates, benchmark results, even some investor stuff.
Right. And our plan is to sort of sift through all of this for you. Figure out how AMD is actually taking on NVIDIA, because NVIDIA's position is, well, incredibly strong.
Mm-hmm. And what do AMD's new chips, like this MI300X everyone's talking about, actually bring to the table?
And what does all this fighting mean for AI itself?
Okay.
For the companies using these things?
Yeah. And we found some pretty surprising things in the sources, like some really big tech companies maybe changing sides.
Mm-hmm. And some specific performance numbers that might make you look twice.
Yeah.
Plus, just the sheer scale of this market.
Mm-hmm.
It's kind of mind-blowing.
Okay, so let's dive in. Where do we start? NVIDIA's dominance.
Yeah, I got to start there. The sources are all clear. NVIDIA is the king of the hill right now, especially for AI GPUs and data centers.
The market share numbers are just, wow, over 90%.
That's what's reported, over 90%. And their profitability, the gross margins are apparently hovering around like 75%.
Which is huge. And this demand, it's just exploding, right? Because of things like ChatGPT.
Absolutely. All these large language models, generative AI, they need enormous compute power. Data centers packed, just packed with GPUs.
And NVIDIA's H100 chip has really been the standard, the one everyone wants.
It's been the benchmark, yeah. Known for its power in these AI tasks.
But, even being dominant creates its own problems. The sources point out some openings for competitors, right? Starting with the cost.
Right. The H100 is, well, it's expensive. Estimates we saw put it between $25,000, maybe up to $40,000 for one chip.
Oof. And you need thousands.
Exactly. That adds up incredibly fast.
And the other thing was just getting your hands on them.
Yeah, availability was a massive headache. It's gotten better. Apparently, wait times were over a year at one point.
Over a year, wow.
Yeah, now it's estimated maybe 2 to 3 months. But still, if you're trying to scale quickly.
That's still a bottleneck. A big one.
Definitely.
Okay, so dominant player, powerful chip, but it's pricey and sometimes hard to get. Sounds like an open door for someone like AMD. What's their answer?
Their main weapon here is the Instinct MI300X GPU. That's their challenger.
And the strategy is basically offer something almost as good, or maybe better in some ways, but cheaper and easier to get.
That's the core idea, yeah.
Yeah.
Offer a really compelling alternative. Target those big customers, the hyperscalers, who are spending fortunes on NVIDIA and maybe feeling a bit locked in.
Yeah.
Give them strong performance, lower costs.
Okay, specs. What do the sources say about the MI300X? What makes it tick?
So it's built on their CDNA3 architecture. The really standout thing is the memory. 192 gigabytes of HBM3 memory.
192 gigs. That sounds like a lot compared to, what was the H100?
The standard H100 has 80 gigs of HBM2E, which is a slightly older standard.
So more than double the memory.
Yeah. And that translates to memory bandwidth, too. The MI300X gets up to 5.3 terabytes per second. The H100 is around 3.35 terabytes per second.
So significantly more memory capacity and more bandwidth, about 60% more bandwidth.
Roughly, yeah. And performance-wise, peak FP16 is about 1.3 petaflops for the MI300X, compared to just under 1 petaflop for the H100.
Okay, so that memory difference, the 192 versus 80 gigs, the sources explain why that's such a big deal for AI, right? It's not just a bigger number.
Absolutely. The material really emphasizes this. That huge memory pool and the high bandwidth are crucial for these massive large language models.
How so?
Well, for AI inference that's actually running the trained models to get results, like generating text or analyzing images, you need to fit as much of the model into the GPU's memory as possible to avoid slow data transfers.
Gotcha. So more memory means you can run bigger models more efficiently.
It's exactly. Or run existing models faster. The benchmarks mentioned in the sources show this. For models like LMA270B, they're reporting the MI300X has up to a 40% latency advantage over the H100.
40% lower latency. That's significant. Faster AI responses.
Right. And they directly attribute that to the memory specs. Some other tests, more low-level stuff, apparently showed even bigger throughput advantages, like up to 5x in certain operations.
Okay, performance looks competitive, especially on the memory front. What about that cost angle?
That's a major part of AMD's pitch. They're claiming lower purchase price and lower running costs. The estimates for the MI300X are somewhere in the $10,000 to $20,000 range per chip.
compared to 25K to 40K for the H100.
Yeah, so potentially half the price or even less. That's a massive difference when you're buying at scale.
And availability. And AMD easier to get?
The reports suggest AMD has fewer supply chain headaches right now, which could mean faster delivery times. Another potential advantage.
So, strong performance, especially inference thanks to memory, much lower price, maybe better availability. Are the big customers biting? Are they actually buying these?
This is maybe the most telling sign from the sources.
Yeah.
Some huge names are publicly saying they'll use the MI300X. We're talking Meta, Microsoft, OpenAI.
Wow. Okay. Those aren't small players. How are they using them?
Meta specifically mentioned using them for AI inference, like for AI stickers, image editing, things like that.
Okay.
Microsoft is adding MI300X instances to its Azure cloud platform, so developers can rent that power.
Right, making it accessible.
And Oracle's cloud division is also getting ready to offer AMD's chip.
What makes Meta and Microsoft jumping on board so important?
Well, one report we saw from NVIDIA identified Meta and Microsoft as two of the very biggest buyers of NVIDIA's H100 chips last year.
Ah, okay. So the fact that they're bringing in AMD chips.
It's a huge signal. It shows these giants are actively looking for alternatives. They want to diversify, maybe cut costs, maybe get specific performance benefits. They're not just sticking with NVIDIA unquestioningly.
That makes sense. Okay, so AMD's got a good product. They've got major customer endorsements, but it can't all be easy, right? What are the hurdles, the challenges AMD faces?
The big one, the elephant in the room, really, is the software. The sources talk about this a lot. NVIDIA's CUD platform.
It's just so established.
Exactly. It's mature. Developers know it. There's a vast ecosystem of tools, libraries, community support built up over, 15 years?
And AMD's alternative is ROCm. How's that doing?
RCM is definitely growing. It supports the key frameworks like PyTorch, TensorFlow. AMD's putting a lot of effort into it, but it's still playing catch-up.
So for developers, it might just be harder, more work to switch or optimize.
It can be, yeah.
Yeah.
If you're deeply invested in CUDA, moving takes effort. That's a significant barrier to adoption, even if the hardware is great.
I also noticed some discussion in the material, in forums or comment sections linked in the sources, questioning if just looking at one chip's performance is enough.
That's a really important point people raise. Real-world AI workloads run across hundreds, even thousands of GPUs working together.
Yeah.
So how well these chips scale, how efficiently they communicate over the network, that's critically important. And some of the recent comparisons maybe haven't fully dug into that aspect yet.
So single chip benchmarks might not tell the whole story for a giant data center.
Potentially, yeah. It's another layer of complexity.
And there was even some debate about which H100 they were comparing against, right? Like the PCIe version versus the faster SXM version, and potential bias in how results are presented.
It just shows that these comparisons aren't always apples to apples. You have to look closely at the configurations, the workloads. It's tricky.
Okay, so software ecosystem, scaling performance, benchmark nuances, those are real challenges. But AMD isn't just betting on this one chip, right? What's their longer-term plan?
No, they're showing a serious multi-year commitment. The sources lay out a pretty aggressive roadmap. MI300X started shipping early 2024. But they've already announced the MI325X, expected by the end of this year, 2024. And they're explicitly positioning that against NVIDIA's next big thing, the Blackwell chips.
Yes, so keeping pace year on year.
And it doesn't stop there. They're talking MI350 in 2025, MI400 in 2026. It signals they are in this AI data center fight for the long haul.
What's the word from AMD's CEO, Lisa Su, on just the overall demand?
He's quoted as saying the demand is just relentless, growing everywhere, exceeding expectations, investment is pouring in.
And the market size predictions, they're pretty staggering.
Yeah, AMD themselves estimate the AI GPU market could hit $400 billion or more by 2027.
$400 billion.
Or more. Another source put the overall AI chip market maybe reaching $500 billion by 2028. It's just enormous potential.
Does AMD think they can actually overtake NVIDIA?
Lisa Su was careful there. She apparently said they don't expect to achieve dominance right now, but they clearly aim to capture a very significant share of this exploding market.
And it's not just GPUs, right? They launched new server CPUs, too.
That's right. The EPYC Generation 5 CPUs. The sources mention these are key because you need powerful CPUs to feed the data into these hungry AI accelerators efficiently. So it's a platform play, complementing the GPUs.
Okay, stepping back a bit. How does this AMD versus NVIDIA fight fit into the bigger picture of the semiconductor market right now?
Well, it really shows where the action is. The sources suggest that AI-driven chips, these high-end GPUs, are seeing incredible demand. But other parts of the semiconductor market,
Like memory or PCs.
yeah, or even some industrial segments, they're not seeing that same boom. AI is clearly the hotspot driving growth.
And it's not just AMD trying to challenge NVIDIA, is it? The sources mention others.
Definitely not. Intel is in the mix with their Gaudi accelerators,
Mm.
particularly Gaudi 2. Their angle seems to be strongly focused on price performance, especially for training models.
Cheaper than NVIDIA.
Potentially much cheaper per unit, yeah. The sources mentioned numbers suggesting Gaudi 2 might offer better performance per dollar than the H100 in some cases, with prices around $8,000 per accelerator in a server bundle.
And NVIDIA has other options too, right? Not just the super high-end H100.
Right. They still sell the older A100, which is reliable, more available, and cheaper than the H100, maybe 18K, 20K. And they have the L40S, which sort of balances AI and graphics, priced even lower, like $7,600 to $9,800. So they have tiers.
One of the most fascinating things I saw in the sources was how companies like OpenAI are navigating this. They need tons of these chips, but they're not putting all their eggs in one basket.
That's a really key point. OpenAI's strategy is super interesting. They're partnering with cloud providers like CoreWeave to get access to huge numbers of NVIDIA GPUs, like over 250,000 units mentioned.
Okay, so they still need NVIDIA.
Yes. But at the same time, they're working with Broadcom to design their own custom AI chip, trying to reduce that dependency. Mass production plan for 2026.
Designing their own silicon.
And they're involved in these massive future data center projects like that huge Stargate project with Oracle, SoftBank, and MGX, supposedly costing $500 billion. It shows they're thinking long-term and diversifying their hardware sources.
And there was that other disruptive element too, the impact of new, cheaper AI models.
Yeah, that DeepSeek example was really interesting. They released these open-weight models that apparently compete well with top proprietary models, but were trained for a tiny fraction of the cost, like $5.6 million.
And that actually affected NVIDIA's stock.
According to one source, yeah. That news contributed to a big single-day drop in NVIDIA's market cap back in January. And it apparently got OpenAI's CEO talking about potential collaboration with China. It just shows how interconnected everything is, the models, the hardware, the costs.
So pulling all these threads together, AMD's challenge, NVIDIA's defense, Intel, custom chips, model costs, what does all this competition mean for, for us, for the listener?
Well, fundamentally, intense competition like this is usually good news for the end users and the industry. It pushes innovation faster, it puts pressure on prices.
So potentially more powerful AI computing, maybe becoming more affordable or accessible over time.
That's the likely outcome, yeah. Lower costs and faster innovation could really accelerate how AI gets developed and used across all sorts of fields.
Okay, so let's try to sum it up. AMD's MI300X is a serious challenger, hitting NVIDIA hard on memory capacity for inference and definitely on price.
And they've got big customer wins to back it up, plus a clear roadmap for the next few years showing they're committed.
But NVIDIA, they still have that huge market share, those high margins, and crucially, the CUDA software ecosystem, which is a massive advantage.
It is, though they do face those challenges with the H100's costs and, at times, availability.
And we can't forget Intel pushing on value, or the big cloud players and AI labs like OpenAI actively diversifying, even designing their own chips. It's not a simple two-horse race.
Not at all. It's a really dynamic, complex battlefield with lots of different forces at play.
Which kind of leads to the final question for everyone listening to think about. Given AMD's sustained push with new chips every year, their focus on cost and memory and these big customer wins, plus all the other competitive pressures, can they really start to significantly chip away at NVIDIA's lead over the next few years?
And maybe more importantly, what will the outcome of this whole fight mean for the pace of the AI revolution? How fast will it unfold? And how accessible will that power become for everyone?